Okay. Hello class, this is Dr. Wezo. We are the Aquaculture facility at Lincoln University, where they rear fish indoors and outdoors.
Okay, all right class. What I'm going to be talking about today deals with a recirculating system used for rainbow trout. The recirculating system provides an aquatic medium the fish live in, they acquire their oxygen from, as well as deals with the waste that they produce. The system, if it operates properly, supplies all the needs the fish have. The key components of the system provide the fish places to actually swim around and eat and just do their day-to-day business, which is referred to as the culture tank. That is the component that we interact with the most, and that's where you can actually see the fish. Then we have components on the other end that remove the solids, the feces the fish produce first, and thereafter we have components where you have bacteria actually actively growing that help remove the dissolved compounds, and then the water is brought back to where the fish are located. The water is reused multiple times before we release it from the system. When we're operating the system as we do it now, we actually have two waste streams. One of which is where we periodically purge the system that collects the solid filtrates. Another component deals with the waste stream that allows us to have a continuous amount of replacement water going into the system that helps it keep it into the proper temperature range we want to be in. That very same system also brings in micronutrients and things of that nature that the fish might need that the feed may not be complete with. There are several aspects to how this system works. If you look at it, the water is relatively clear, even though we're throwing quite a bit of feed in there. When the system's operating the way it's supposed to, the water spins, not unlike a commode, and when it does so, it concentrates the solids towards the middle of the tank, where the plumbing then preferentially removes the solids from the water quicker than the balance of water in the tank. And that reduces the time that we have solids physically actually in there with the fish. Now bring them on down. Now here we have a series of tanks. In aquaculture, we often have to keep our size categories separate. Large fish and small fish do not always get along. Bigger fish tend to eat smaller. If they don't do that, they at least bully. So we keep the fish sorted based on size. Hence the large number of tanks. Now the water that's coming from all these culture tanks, we actually have 9 culture tanks in this particular setup. It's coming through a horizontal pipe that's underneath. It comes up here through this device here, and that is referred to as a standpipe. The height of this dictates the water level in the tanks upstream of it. The water comes in here, and if you were to watch carefully, every now and again you'll have a solid, a particulate, usually a piece of feces that comes out there. The water comes into this volume here, which is referred to as a sump. This is the lowest component of the whole system. The sump water is pulled from it by way of this pump right here, which is called the sump pump. The water pulls up through here, and then it goes through this device right here. This is the feed filter in this case. It removes the solids. It filters the solids out. You've got a large mass of plastic beads. The water percolates through. The solids collect in that. And then the filtrate, in other words, the water basically have the solids removed from, comes up through this plumbing here and goes back through the large green soda pop bottle shaped thing. Inside of there, we have large amounts of plastic as well that are being rolled around effectively by the water current, as well as air being injected into that volume. It rolls around and provides an ideal habitat for the bacteria that then consume the dissolved components the fish produce, particularly ammonia. The air going in there supplies oxygen the bacteria need so they can do their work, because they need oxygen to oxidize the ammonia and also result in nitrite. And from there, the water goes back to this plumbing here and is dispensed back in the culture tanks. And that enables the water to be reused. Now then periodically, the feed filter, we stop its operation and we back flush it. That means we stir it all up aggressively and then we flush water through it backwards, effectively through the media, and it discharges the waste through this pipe. And the waste is so concentrated, the water appears to be almost like chocolate milk. And that's when the bulk of the solids that this thing collects is actually removed from the system, and that is discharged ultimately in the environment. And it's that waste that we do pay attention to most of the time. This is the bulk of the nutrients leaving the system. But we also have a steady flow of nutrients leaving here. We always have a little bit of water in excess going into the system, and that's where the water is being allowed to go out this way. Okay. Here we have an alternative to the system I just shown you inside, which is an indoor system, which is much more tightly controlled, but it's also not as frequently used here in the Midwestern U.S. This particular system here, based on the pond, is the more frequently encountered type of aquaculture. With this type of a system here, the water is obviously not as clear. The nutrition that's supplied to these animals, a big chunk of it comes from the natural forage base that's actually occurring in the pond. These ponds actually have a lot going on in them beyond simply the fish themselves growing. Here we've actually got a food chain that produces food and oxygen actually in the pond itself that helps drive the production of the fish that we're concerned with. As a result, it's not as clean looking. We've got other forms of animals and plants growing around the perimeter of the pond. Notice the dragonflies. Okay, this system is much more complex. The waste that the fish produce is actually processed by the pond itself, actually where the fish are. As a consequence of that, when we're doing pond production, we generally do not have as much production per unit volume of water and even acreage as what you would get when you compare it to our indoor systems where we have much more control. But generally speaking, if you have the land available and the water, this system is more foolproof. It's easier. Mother Nature knows best. It's often easier to construct. It usually requires less skill to operate, but it requires more land and it usually requires more water.
Hello class, we are at the poultry facility at Lincoln University. We want to talk about research and chicken production. This is Kim Cash. She's responsible for this research and setting up this facility in collaboration with Aquaculture.
Yes. I am working on a project with Cornish Cross chicks. We hatch them out at, it takes 21 days for a chick to hatch. So June 15th they hatched. They're approximately 3 weeks old today. We weigh them every week, and they have doubled their weight every week so far. Our goal is to see if we can move them outside and have them utilize the insect population as part of their feed. So they'll be on full feed overnight, and then during the days we're going to try and get them to forage for natural insects and see if they can maintain weights with the reduced feed intake by being able to use that natural population. We also have got a group of Sussex chicks, which are actually laying pullets, and they are more of a dual-purpose bird, but we're going to use them for egg capacity later on. We're going to look at changing their feces to use it better as an amendment in soil. So this is kind of our operation currently. We've got tubs that we're raising them in. They each have a gallon water and a 6-pound feeder, and they're on full feed, so they eat as much as they want. And they're weighing in at somewhere between 900 and 1,100 grams right now, so at 3 weeks old. At 6 to 8 weeks, they'll weigh approximately 5 pounds, and then they'll be ready to go to the butcher for the slaughter process. So that's pretty much the gist of it right now.